In this video, we're going to talk about the SPDF sublevels. What you need to know is that S has a spherical shape, it's like a sphere. P has a dumbbell shape, it can be drawn both ways. D is like a clover leaf, and F has some unusual shape which varies, and I really don't want to go over that. But some things you need to know. The number of energy levels is equal to the number of sublevels. So when n is 1, you only have one sublevel, S. When n is 2, you have two sublevels, S and P. When n is 3, you have three sublevels, 3S, 3P, 3D. When n is 4, there are four sublevels, 4S, 4P, 4D, and 4F. The S sublevel can hold up to 2 electrons. And you need to know that every orbital can hold up to 2 electrons. So S has one orbital. Now in the periodic table, the S block is really the first two columns, group 1 and group 2. So that's the S block. P can hold up to 6 electrons. If you notice the P block in the periodic table, it's like group 13 to group 18. You can see those 6 elements there. P can hold up to 6 electrons. And because every orbital can hold up to 2 electrons, P has 3 orbitals. D can hold up to 10 electrons. The elements in the D block, starting with you have like zinc, copper, nickel, those are in the 3D sublevel. And if you look at the periodic table, there's 10 elements there. D can hold up to 10 electrons. And so the D sublevel has 5 orbitals. F can hold up to 14 electrons, and F has 7 orbitals, 1, 2, 3, 4, 5, 6, 7. So those are some things you want to keep in mind. By the way, whenever you have the S sublevel, L is equal to 0. For the P sublevel, L is equal to 1. For D, L is equal to 2. And for F, L is equal to 3. So you need to be familiar with these 4 quantum numbers, N, L, ML, and MS. We talked about N already. This is the main principal energy level. L represents the sublevel, which is associated with S, P, D, and F. ML, it specifies the orbital. S has one orbital, and it has a value of 0. P has 3 orbitals, and it has a value of -1, 0, and 1. D has 5 orbitals, which varies between -2 and 2. We're going to talk about that soon. MS represents the electron spin. Inside an orbital, you can have an up arrow, which stands for +1/2, or you can have a down arrow, which has an electron spin of -1/2. So let's talk about how to identify these quantum numbers. Let's say if you want to identify the 4 quantum numbers for the 3p5 electron. N is going to be this number, N is 3. Now, P will tell you what the value of L is. Keep in mind, for S, L is 0. For P, L is 1. For D, L is 2. For F, L is 3. Now, P has 3 orbitals, as we talked about. And because L is 1, ML is going to vary between -1, 0, and 1. Now, we're focused on the 5th electron. So here's the 1st electron, 2nd, 3rd, 4th, 5th. The 5th electron lands in this orbital where ML is 0. So therefore ML is 0. MS is -1/2 because the 5th arrow points down. You always start by drawing the arrows up and then down. So those are the 4 quantum numbers that corresponds to the 3p5 electron. Let's try 2 more examples. Let's try 4d4. N is 4, and for D, L is 2, because for S, L is 0, for P, L is 1, and for F, L is 3. Now the D sublevel has 5 orbitals, and so ML can vary between -2, -1, 0, 1, and 2, because L is 2. So here's the 1st arrow, 2nd, 3rd, 4th. we're interested in the fourth arrow, and it landed on the orbital that has a value of 1. And because it's an up arrow, the spin is positive 1/2. Alright, for the sake of practice, let's try one more example. Let's focus on the 5f13 electron. So n is 5, L is 0 for S, L is 1 for P, L is 2 for D. For F, L is 3. And for the F sublevel, there are 7 orbitals. And ML can vary between -3 and 3 because L is 3. So we're interested in the 13th electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is. And it landed in this orbital, so ML is 2. And it's a down arrow, so the electron spin is -1/2. So that's how you could find the 4 quantum numbers given the electron. Now, Pauli's exclusion principle states that no 2 electrons can have the same set of 4 quantum numbers. As you can see, these quantum numbers are unique for each electron. This one electron has a unique set of 4 quantum numbers. So if you're given these 4 quantum numbers, you can identify what electron we're talking about. Let's try that. So let's say, for example, if n is 3, L is 2, ML is 1, and MS is -1/2. What electron are we talking about? Which electron is identified by these 4 unique quantum numbers? So we know we're in the 3rd energy level. When L is 0, it's S. When L is 1, it's P. When L is 2, it's D. So we're in the 3D sublevel. D has 5 orbitals. And because L is 2, it varies between -2 and 2. Excuse me. Now we know that the electron is in this orbital because ML is 1. And we know the arrow has to be a down arrow. So let's count it. 1, 2, 3. Start with the up arrows. 4, 5, 6, 7, 8, 9. There's our down arrow. So these 4 quantum numbers corresponds to the 3D9 electron. Now let's talk about electron configuration and orbital notations and so forth. Let's say if you want to write the electron configuration for, let's go with phosphorus. Now, if I remember correctly, I believe phosphorus has 15 electrons. Let me just take a minute and verify that with a periodic table. And yeah, that's correct. Now, the first energy level only has 1 sublevel. The second energy level has 2 sublevels. The third energy level has 3 sublevels, so 3s, 3p, 3d. The fourth energy level has 4 sublevels. So let's say if you want to write the electron configuration for phosphorus. The configuration, the exponents has to add up to this atomic number. Now keep in mind, S can hold up to 2 electrons, P can hold up to 6, D can have up to 10, F can have up to 14. And we're going to write it until the exponents add up to 15. So let's begin. So 1s can hold up to 2 electrons, 2s can also hold up to 2, 2p can hold up to 6 electrons, and 3s can hold up to 2. So right now we have 2 plus 2, which is 4, plus 6, which is 10, plus 2, 12. We only need 3 more. 3p can hold up to 6, but because we only need 3 more, we're going to stop at 3p3. This is the electron configuration for phosphorus. Now, let's say if you're given a question and they ask you how many s electrons are in phosphorus. After you write the configuration, you can answer the question. So there are 6 s electrons in phosphorus because if you add up the exponents, you get 6. If they ask you, hey, how many p electrons are in phosphorus? Simply add the p electrons. 6 plus 3, there are 9 p electrons in phosphorus. Now let's refresh the page, but let's keep the information that we have. So we said the electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, and 3p3. But now let's write the orbital notation for phosphorus, or the orbital diagram. So this is the 1s orbital. S has only one orbital. Here we have 2s, 3s. Notice I keep it in the same column. Then to the right of that, just above 2s, we have 2p, which has 3 orbitals, and 3p. Now, as you go up, the potential energy increases. Now, according to Aufbau's principle, you need to add the electrons in increase in order, which means you start from the lowest energy level and then you go up to the highest energy level. So we have to start with 1s. We put the first electron here. We don't put the next one in 2s. You have to put the next one in 1s. You have to go in order. That's Aufbau's principle. 2s2 is filled. Now, according to Hund's rule, whenever you're filling electrons in degenerate orbitals, you have to fill them one at a time. The word degenerate means that the energy is equal. So these 3 orbitals have equal energy because they're at the same height. So therefore, they are degenerate orbitals because they have the same energy. So whenever you're adding electrons here, you add it one at a time according to Hund's rule. So 1, 2, 3, 4, 5, 6. 2p6 is filled. So next, according to Aufbau's principle, we move into 3s, not 3p, because we have to go in order of increase in energy, or increase in potential energy. So 3s2, and then based on Hund's rule, for degenerate orbitals, which are energy levels which are orbitals that have the same energy, we have to fill these orbitals one at a time. So 1, 2, 3. That's how you fill the orbital diagram for an element. Write the electron configuration first, then put the arrows in. So that's it for this video. I think we covered a lot, and I have other videos on quantum numbers, so feel free to search YouTube for those. And so that's all I got for today. That's my 2 cents.